Alright, hello and welcome to another coding video on my channel. So, I will start a very new series here, a lot more casual. So, what I will be doing today is I want to create a fractal tree and show you how that is being done. You know, with going 2 branches out and then 2 branches out. It's very simple actually, but we will have some recursion, some graphical stuff and all that stuff, yeah. And yeah, like I said, I use just the setup that I would usually use to make any sort of idea, and that is my QPL library. I am making games with that. I'm currently developing a game, and yeah, I thought I really want to do some videos, but I guess in order for me to make it easy, I will just have to make it easy and use my QPL library. And yeah. So let's go to this setup here and see how this goes. So yeah, in the first episode I will show how to set this up. We will make a template file, and from there we will just copy that and always have a new project ready. Alright, so let's go here, let's extract that. So let's paste this here. You will also have to download SFML, which is in the description or here on the GitHub. Now let's remove this. Now we want to make a Visual Studio project. So let's open Visual Studio, my IDE of choice, of course. New project. And like I said, this is a template project, so let's call this QPL. And let's add a new item here, the main file, main.cpp. I like my source folder. Now we set up SFML. So let's include that. And I will be linking my library statically, which means I will not include the DLL files and the library files of my library. And the reason is I want to be able to edit my library at while coding, because that's what I usually do. You know, I make a game, I have some feature that I haven't implemented yet, and then I just add it to the library. So yeah, let's click here and we have to link the SFML library. So let's do that. Click on lib here, you know the drill. Let's go to C++, language. And here, and also while you're doing all of this, make sure you are all configuration, all platforms. Okay, now we have to set the SFML linker names here for the input. So let's go to release mode, paste that here, and the debug names. Again, I'm not copying my my QPL stuff because I will do it statically. Click on OK. And that should be all of it, except the C++ preprocessor. We have to add QPL DLL exports if we want to do this statically. So let's add that. Well, damn it, it should be all configurations, and now we add it. Okay, now let's copy the QPL hello world. This will just make a black screen. And before we finish, we have to copy the DLL files of SFML. So let's grab them here. So we have to add the CPP files. And what I will do is I will add both of them, so HPP and CPP. And this way we can statically link the library, which means we are building the library as we have to. Go here, QPL. And then you want to add all of these HPP files. Add existing file as well for the CPP files. And then we will do the same thing for the QSF folder. I guess we are in the CPP directory right now, so let's be a little bit more efficient. Add all of those. And now we just need the QSF header files. And then we have all of that in our project. Okay, here we go. And now we should be, let's rename this QPL. Now we should be able to build. Now the first time compiling will take a bit because it has to build all of these files, but after that it will cache all of this information, or I'm not actually quite sure how it does it, but the first time is always slow, but the second time is very fast. Basically only has to build your local project here. So yeah, about the question, should you build this with the library DLL files or statically? You know, it's a lot easier with the DLL files. It's a lot faster the first time especially. But if you do it statically and you want to, look how something is implemented, that's very easy to do. Also, if you do some changes, you can you're very welcome to just submit them to the GitHub, and that would be pretty cool. But yeah, let's see. Okay, so this built it successfully, and here we have it. Here's the SFML window with the QPL framework. Very good. So now, to finish this template here, we simply delete the VS folder. Well, let's first close this. It doesn't like doing that. And now the whole thing is pretty small. It's only, whoa, it's still pretty big. Let's see what else. I guess this one is pretty big. Yeah, 7 megabytes. So this will be the QPL template. And now we can start making the fractal trees. So let's do that. So because I deleted this folder, we have to build it again. But through the magic of editing, it will not take so long for you. But let's make it release mode, and I see you on the other side. I guess while it's building, we can kind of start thinking about the idea here. So we want to start by making this segment here, this very first segment, and basically branch out. And we will do this recursively. So we want to have a struct of a segment, and then make like a tree struct which can recursively add segments to some vector. Yeah. So one thing I can already talk about is when you have a line and you want to create like a rectangle around it, and later on it will be different width here, as you can see, because we want to do it like this. So we don't have this visual bug here or here. And so what's important about a line is a line has a normal. So the normal is the perpendicular line that goes out. And this is always normalized. So this will be normalized to be 1. So it doesn't matter how long this is. It will always be a length of 1 here. So of course a line can be it can be like tilted, but the normal will still be perpendicular to this line. And it's calculation basically thinking about this to be a rectangle like this, and then you use Pythagorean and stuff like that. We will get into that. So here it is built. Let's take a look at this wonderful empty project. Beautiful. Okay. So we want to make a struct segment. So a segment has a line. So a line has 2 points. Now I can make 2 points. I can also use my QPL straight line. Let's use that for now. And we want to draw it somehow. So we want to make a shape which can have like, it's not so easy to describe. It's not very, we will initially make it a rectangle, but later on it will be like a trapezoid, I think. So whenever you have some weird shape, you always go with SF vertex array. In my case, I have the QSF vertex array, which just offers a bit more functionality. And to make this segment struct drawable, we simply add a void draw, a draw object, and declare this constant, and then this draw object can draw anything. So here we just set in the vertex array. And what happens now, if we add a segment here, we can simply say this draw this seg. So why can we do this? Well, this structure segment fulfills the QSF has draw object fulfillment concept. So for example, QSF has draw object segment. This will give us true. And for example, if I remove the constant here, this will be false. And this also will throw. So very convenient. You can make anything drawable without inheritance, which is beautiful. Okay. So now we draw this vertex array, but it's empty right now. So I guess we want to make like a make shape, where we also set the line. So we have to specify like some things here, right? We have to say the position 1, position 2, and I guess a thickness, and also a color. And then we can let's start with the positions. And yeah, so let's try to think about making this vertex array. So like I said, we have the line here. We can calculate the normal, and we can find these corners here by arithmetic. So we simply multiply the normal from this point left or right and left or right. Yeah, and so again, how do we get the normal? We say line dot normal. And by including my library statically, you can always click F12 here and look how this is implemented. So this is normalizing the position to be on the 0, 0 coordinate, and then it's dividing by the length, and the length is basically rearranging the Pythagorean theorem, and that's it. Okay, and then let's see. So the vertex array, you always have to set the primitive type. You know, this could be points or lines. In this case, we want to make quads, and then we want to have 4 vertices. So the first vertex, we can set the position and the color. So let's start with the position. This will be the first position, and then we subtract the normal times the thickness. So why do we subtract? So we start with this one first. So this will be the first index. This is the second, the third, and the fourth. So you always go clockwise around your shape when you do primitive types, and especially quads or triangles. You always go clockwise. Then the second one is we simply add this this corner here, and this one will simply have the lower position here. That should be it. Can I iterate over this vertex array? I think I implemented that. Yes, and then I set the color to be the color. Very easy. So let's say make shape. Let's just choose 100 and 100, 200, 200. Thickness, let's go with 5. And let's just go white for the color. Alright, let's see. Okay, there we go. And apparently there is a little bit of a thinness here. What happened? What happened to our shape? So by the way, before I go into that, I want to show something. A feature of my QPL library, which is the view rectangle. Now this is a way to make it very easy for me or anyone else to explore the screen. So you basically set the hitbox, then you update it. An update is just like drawable. It looks if it has an update function. I will go into that maybe later, but not important right now. We simply pass in the view whenever we draw. As you can see, here's the screen, and now I can drag it, I can zoom in, and this is helpful if we want to observe stuff like this. So it appears as if, I don't really know, to be honest. Let's see. This doesn't really give me any further information. Yes. So, okay, I see the arrow. So I said we have to go clockwise. So we go minus, plus, plus, minus. But right now we go minus, plus, minus, plus. So we have to switch these two signs, so we don't cross. Right now what we do is we do like a you know, a thing. What is it called? The clock. the sand clock timer. Okay, and this looks perfect. And as you can see, here you can very well see this perpendicular line, which we multiplied by the thickness, and it looks beautiful. And with this we can build the tree. So let's make a tree struct. Yeah, so a tree has a segment, and in order for the recursion to work, it has a vector of trees. Yeah, and now we copy this draw function here, and draw works by drawing the segment and the trees. And the magic of my C++20 updated QPL library is we can even draw containers and stuff like that. So we want to make like a grow function where we have some kind of starting position. Yeah, that's it for now, I think. And in order to make this recursive, we have to have some recursive function. But I usually pass these variables on the stack through the parameters, so I make like a grow recursive function here. So this will be also the starting position. Then what do we need? Well, we want to like branch out, right? So we have to have some information about an angle. We also, if we go recursive, we could just go infinite. So we have to stop at some point. Let's just save the depth, and then we can check if the depth exceeds some value. We can return out of this grow recursive function. I think that's really all the information right now. Yeah, okay. And then grow simply calls grow recursive, where we pass in the starting position and the angle 0, I guess, but will be different in order to grow upwards. So we start here, we grow up. So what angle is it when we go up? You have a circle, then you have a pi. You have you have pi here and stuff like that. In our case, we go against the circle, so we go negative, and this will be negative pi halves. So in order to go up, we go an angle of negative pi halves. That's a little bit a mouthful, but and let's see. So we want to create a segment, so make shape. So we need the first position and the second position. Yeah, well, we need to calculate the second position here. So position 1 is obvious, it's the starting position. Position 2 will be, we have to know something about the length of the segment. So what we could do is we could pass a length here, which we decrease over time. Because if you look at this picture, for example, the length actually decreases. But we know how deep we are, so we can simply calculate this. So the length, we can just say we want to have 0.8 to the power of the depth, and then let's multiply this by 200. So the angle, well, we have to say like this, so x and y times the length, and convert the angle to x and y. Auto x, y equals, so x is the cosinus of the angle, and y is the sine of the angle. I mean, that's nice syntax sugar here, but let's just make it like this. This is the angle position. Alright, so yeah, now we have the second position calculated. I think that should be right. We pass this over, so position 1, position 2, thickness, let's just go with 10. We will also decrease this over time. And the color, just go white for now. Yeah, let's actually do the thickness as well. Go way down, like 5. And so this should decrease over time. Okay, and now the magic about the recursion. So we want to resize the trees. So we want 2 branches, and then we call this recursively. So on the first branch, we call the recursive function. We pass in, well, the new starting position will now be the position 2 actually. And then we will add something to the angle, or we go left, so decrease by like 0.1. And then the depth, we add 1 to the depth. The same one for the second branch. We add delta angle. I guess we want to save that. So delta angle equals 0.1. Okay. And also we have to somehow break out of this function. So let's make like a max depth. Let's set 15, and if depth is greater or equal to our max depth value, then we return. Okay, and let's see. Now we want to add the tree here. So we draw the tree and we grow the tree. So we want to grow it out of the bottom of the screen. So let's make, so position.y equals the dimension.y. What is this? Position. And x shall be, I don't know, let's just go with 100. Or let's centerize it. Why not? And then let's call tree.grow out of position. And let's see what we have. So we should, if I did it correctly, we should have something here. Let's see. Alright, there we go. Yeah, that looks pretty good already. If you compare. Need to change the angle a bit. But that already looks pretty good. So as you can see, obviously we want to fix this here. And we will have two thicknesses. And yeah, let's start with that, I think. Okay. So we want to basically just add thickness 1 and thickness 2. So we have to make two thicknesses. So let's do that. And I guess we simply add +1 to the depth to get the next thickness. Yeah, there we go. Now it's very nicely connected. And we don't have this visual impurity. Very good, very good. Alright, let's think about the next one. So I would love to play with this angle, right? To have like a slider here which will allow us to change the angle of these branches. So let's add that. So I have my QSF slider function. This has some template of a value that we want to slide. We can immediately draw this, but let's not draw it with the view because the hitbox actually doesn't get updated by the view. We set dimensions. Let's just go with like 630. So this is the dimension of the slider, and the second one is the dimension of the knob. You will see what the knob is. Let's set the position. So I guess we can centerize this. So this dimension dot x divided by 2, and then we subtract half of the dimensions of 300, and this is just 0. Yeah, and now we set some range. So we want to start at 0, and I guess we go to pi. And here we can already set a starting value, and let's actually go with 0.2. Now we update this. So if a slider value changed, then we have to rebuild the tree. So this tree delta angle is, let's get the value here, and then we grow again. I guess this is annoying, so we might just, yeah, let's just do this here. So we just pass over the dimension of the screen. This should be easier for us. I don't know why IntelliSense doesn't say I have a dimension here, but whatever. So when we grow, we actually have to kind of clear the recursiveness. So let's say we clear the trees, and then we grow it again. In case we change like the depth, but we don't go as far, you know, stuff like that. You could have some weird visual bugs by calling this again. Okay, there's the slider. I guess we want to move it down a bit. And yeah, what the hell? I guess I did something wrong. What is that? And also, we are moving the thing to the right because actually when I drag it here, I also move the view. So let's do that first quickly. This is actually pretty simple. So if slider, if we are not dragging, allow dragging is the variable here, we set it to false, otherwise it's true. So I guess we can simplify this to be not dragging off the slider. And yeah, it seems like the angle did a bit go... yeah, okay, I already know why. Okay, but now we shouldn't, yeah, now the view doesn't get moved. Actually move this a bit down, please. Where is it? Let's go like 30. Yeah, so because we have a delta angle here and we create trees, we just reset this value. So what we should do is we have to actually pass this value down and not use the intern delta angle. Yeah, and then we pass that also down the recursiveness. And here we pass in the real delta angle value. Maybe we can rename this. Let's go D angle. It doesn't really matter too much here. But now we should get that the new delta angle affects all branches. Let's see. Okay, here's the tree. No, it still doesn't do it. Why? Oh, because I actually didn't apply it. Okay, but now it should work. Oh yeah, here we go. So now this slider affects the whole tree. And look at that, I think that's really beautiful. And yeah, that's, I mean, expanding this angle, it turns into like a snowflake or some cool fractal. Very interesting. I can't wait to play like with colors, and also I want to branch out like some random times here and make it look like a real tree. Yeah, there's a lot to be done here. I guess I also really want to add a slider for the maximum depth. I think that would be really cool to see this thing growing, you know? So let's do that. Let's add a slider. Oh, I guess I call this the angle slider, and this is the depth slider. Okay, have to change out of this. The depth slider, I guess it's not a float value, it's a size value. Maybe just save the dimensions here. So slider dimension is this, and knob dimension is that. Then we can also replace this with slider dimension dot x divided by 2. And now we can basically copy this here, place this with depth. And the range is of course a size value, so I guess let's go 1. And how far do we want to go? Let's go with 30, that's plenty enough. And let's start with a value of 10. And then we have to copy this. So slider depth. So this is the max depth value here. Okay, that looks good. Now we also have to incorporate the other slider. So how do we do this? Well, let's just make a boolean slider angle dragging or slider depth dragging. Dragging gets false. I know you could do this like a one-liner, but I prefer some clarity here. Okay, and we have to draw that. And that should do it. I guess we also will have the same problem because we pass on, we create new trees and it will be defaulted to 15. So I guess this is a good time to make a grow state where we do some little variables that don't change, but we don't want to spam all of this parameter stuff here. So we will have a delta angle here. Now we can rename this back. And we will have a maximum depth, so size. And we will just replace this with the state. This will be the state. This will be the state delta angle. And we need the maximum depth. Where is it? Here. Yep, like this. Then we have to set up the state here. So it's the grow state dot delta angle. And maximum depth. I guess in order to save some, yeah. Now it comes to my mind, because we add these trees, we always have this in the memory. I don't like that. Maybe we just do like a struct, like a tree builder, and this calls the recursive function. And this just has a tree, the main tree, and yeah, we can draw this like this. And here we just steal this. We have to clear the trees and call this. Now this should work better. This is the tree builder. Oh, that's not the tree. And this should work. So let's hit compile and see how this tree builder performs now with the slider maximum depth value as well. I guess the two sliders are exactly above. Yeah, that's of course a thing. So let's go 70. Okay. Ah, yeah. As you can see, we can, and this gets very computationally expensive. Holy moly! I have 2 GB of RAM. Okay, that was too much. I mean, I guess it makes sense. Okay, let's terminate this before I just yeah. Yeah, I mean it makes sense though. Like it's 2 to the power of n, and we were like 20, so that's like what is that? That's like 1 million trees. So 4 million vertices, probably more than that. I don't know. Whatever. Let's just change the let's just change it to 20. Yes. Should be a little bit more family friendly. Okay. Yeah. I guess yeah. I mean it's pretty cool. And once you have it, you can do that. I like it. Yeah, so what can we do next? Oh, that's a lot of vertices, you know? Insane. I mean, it looks so cool. That's the power of recursiveness. It's awesome. What can we do? Yeah, so one idea again was to add some random branches. I think that's definitely what we want to do. Maybe we can also add, can try like making 3 branches. I guess that escapes a lot faster. We can also change, modify this exponential value here. That's what I want to do. Let's do that next. So exp value is 0.8, and we add that to the state. So this is simply state.exp value. And then we can add another slider. This is F64. And I guess before I go like 30, 70, I will just make this easier for me. So this is a counter. We go counter plus times 40. Yeah. And then we just copy this. And this will be exp. The range goes from 0.1 to 1.0, and we start at 0.8. We copy this. exp. I guess we make this a little bit more nicer, so changed, and then if changed, we rebuild the tree. And you know, whenever you have like a big function growing, it's always a good time to split things up a bit. So update sliders, move all of this here, call this here. Yeah, this is exp. This is exp value, and that should work. No, we have to add slider exp dragging. So let's see, what do we have? Okay, something broke. But what? what is happening. Is this just one branch? I'm a little bit confused, I can't lie. What is this? What did I break? Let's see. So I guess this value was never really changed, but why? Oh, this is this is not a... Yeah, okay. That's why you read your warnings. It will somewhere say trying to set a double value to a size value, and then you immediately know what's up. I guess you should always treat warnings as errors in the compiler settings. Yeah, this is pretty cool. As you can see, we can like grow it artificially. I guess we can... No, going outside of 1 is kind of stupid. But yeah, this is pretty cool, playing with the EXP value. Yeah, this is great with this one, because now we have more like to zoom in. That's awesome. I like it. That was a good idea. I like that. Yeah, this is some Fractal stuff. And I guess this is a good time to add like more branches. I want to do that. Just for the fun of it. How would I do that though? I guess I add it to state and say like branch number, and we have to somehow go through this range. I mean, that's yeah, that's possible. So we resize to that, and then we loop over it, and then so the progress in the for loop is, it should be a double, so I divided by state.branch number -1, and then angle is progress times delta angle times 2, and then we subtract delta angle. And now we simply call trees at position i.grow minus let's go loop angle, or branch angle rather. Yeah, minus it's plus branch angle, as we already can go negative. And now we have to set this. Let's go with 2. I guess let's add another slider. We can never have enough of those, right? Branch size. Branch size. Just a lot of copying. I guess it's some could say, yeah, make like an array, but they have different templates, so I would rather not, to be honest. Branch size. Then you make like a vector of scd_any. I get it. We add this here. Branch number. And we go here. This is a sized thing, so we go 1, 2, let's go 5, I guess, and we start with 2. That should be it. We draw it. Okay, let's see. Making a lot of sliders. They definitely require some, maybe some font. Okay, caught exception, bad allocation. Makes sense, and I guess I know why. Because we don't set it. State.branch number is this branch number. I'm pretty certain that should fix it. I don't know why it threw an exception though. If it's 0, it should just... Maybe trees resize 0? That can't be it. Okay, it works. So now if I... Yeah, now we have 3. That's pretty big. And we make this down. Make the angle up. Yeah, now you can very nicely see half a gigabyte of RAM. I guess we have to decrease maximum depth. Hello. Uh-oh. It's very beautiful, but I have too many branches. And this is the EXP value. I definitely have to name these because I'm losing it. Yeah, this is it. This reduces my lag. I guess... Okay. I just realized something. I think I know why this is so slow. Because I have 1,000,000 vertex arrays and I'm not using vertex array as I should. Oh my god, I'm so stupid. I have to make one vertex array and... Okay, but that's very easy actually. Oh my god, that's quite... Like, look here, I have a vertex array. This thing can hold millions of vertices, and instead of, using it by inserting millions of vertices, I make it hold 4 and then make millions of those. So, how should I do this? I have to make like a vertex array collection, so let's make a namespace. Here we make the vertex array, and I guess I initialize it here. And resizing is not what we'll be doing. We will instead, we just add always 4. Size equals data VA size. And then we say this and that and this. Yeah, and now we have to change this. I guess we can copy this because we will have 2 colors later on as well. And in draw, we definitely, we no longer draw. That's the thing. We no longer draw anything. We just draw. We just draw data VA. And of course, we have to call data init. And that's basically it. I hope this works. And it should make it very fast I hope it makes it pretty fast. I guess it's still a lot of vertices, but still. Okay, this looks like a bug. Oh yeah, I know what's happening, I think. Yeah. Interesting bug, for sure. Yeah. Of course I have to clear. Let's just make clear. V8 clear. So when I want to grow, I have to clear this as well. So here we say data clear. Yep, that looks pretty good. Let's see. Yeah, this is faster. This is quite a lot. I think. Yo, this is cool. Very cool, very cool. Very cool shapes. I kind of want to print out how many vertices I have. So let's I guess I have never added a font to the template even, so let's do that. Windows. I'm a boy for Arial, so let's do that. All right, and let's add that here as well. So we have resources. Oh, that's a bit much. Wait, that's Calibri. What the hell? Okay. I just need Areal, please. And let's copy it here, paste it here. And let's go add font, Areal, resources. And then we add some text. So QSF text, vertex, text, vertices. Is it vertices? Vertices. Yeah, right. I knew there was something wrong. Alright. Which of course we will draw in the init. I guess, whenever you have too much code, you make a little init helper function. Let's just make this for sliders. And close this. Okay. And now vertices text, set font, Areal. And then let's set character size 22, should be it. I guess position, just go 30, 30. And then updating, so whenever we change this set string VA, I have to change this namespace, vertices size. Yeah, let's actually change this namespace. It's making me a bit mad. So magic of replacing, replace data with VA. Exactly. And let's hit compile. So now we should have a little text that displays how many vertices we have. I guess I want to add like vertices like this. And by adding text, I will definitely add some text to the sliders. Okay, so now we already have 88,000 of those. Holy. Yeah, I mean, it is exponential, to be fair. It's 2 to the power of n versus 3 to the power of n. So I guess I can understand even that my yeah, this is insane. 1 million vertices, but look at that. That's pretty impressive. I guess I wish I could decrease the thickness. Yeah, that will be more sliders. Because, yeah, there is definitely a performance improvement. I mean, 1 million vertices in like 20 frames per second, that's not too bad. Yeah, I just have to change. Yeah, I mean, it's 3, 3, 3, 3, 3. That's insane. I want to change, or like the opacity. Yeah, the color. Oh man, we will definitely get to the color in a second as well. But we need yet another slider. So let's go like how do we call this? So initial thickness, and we say that yeah, we say here state dot initial thickness, and we pass that in the tree builder as well. That was 4. And now yet another slider thickness. This should be very much of a routine by now. I mean 0 to like 10. I mean 10 is too much, but yep, there we go. Then we copy this changed here, this slider thickness, initial thickness. Can we somehow make this more beautiful with some lambda maybe? Let's think for a second. I guess yes. Internal error, okay. I don't really buy it. Let's just not do that. Not make this a lambda, let's just make this a member. Update slider help. This is the slider and this is the value we want to change. You know, C++20 you can just make auto. Yeah, so we just copied this. And then do it like that. And then value equals slider. Yeah, this should work. And then we have a bool changed. So let's see if this works. So we pass in slider angle and then we want to change tree delta angle if that is the case, and we have to pass and change. Yeah, that seems to work. Alright, that's pretty good. So now we can just replace all of this nonsense. And again, what a nice addition with auto. I mean, it makes your life just so much easier. Not having to type always template. I mean, don't get me wrong, I always feel some kind of joy whenever I have to write some templates, because I mean, at first that was definitely not the case, but the more you use them, the more you kind of love them. Thickness, okay, that should all be it. What did I actually add? Yeah, thickness, okay. Maybe I can also do some magic here. But should I? Yeah, I guess I will. Yeah, this is useful because we will add text later as well. We have the slider, then we have the range, so I guess we don't need references, and then a value. And that's it. Look at that. So now this is the one. I guess we have to keep track of the counter, so but this is QPL32. Let's not get too crazy about this. And these are some const x per slider dimensions. And this slider. And then we have this one finally. But yeah, I mean, just look at that. That's so much cleaner. And this is of course a member function. So let's stay consistent. Let's try to hit compile and see if anything it's not as easy as it seems. Okay, it works. Very nice. Oh my god. Look at them sliders. They are just, yeah. Something has gone wrong. But what? Ah, yes. Classic. Yeah, here we have the sliders. I guess something still went wrong though. And this is not inside the view change. Okay, oh, this was... What the hell is going on? What did I do? Oh my god. I have no idea. Oh yeah, this is the thickness. I see it now. Oh my god, look at the range. Yes, yes, yes. Min-max value. I don't know. Like, this happens so often to me. I'm coding and I'm in my world, and I just don't double check my stuff, you know. Insane. Okay, here we go. Yeah, I have to do that. I can't work with this. Where is it? The slider thickness, but it should be considered. Oh, this is just changed. Okay, so I guess it's also time to add this. I guess let's make this a little bit more beautiful. So we have any slider dragging equals false. And before we go into the update sliders, we set this to false. And then if slider dragging, we set any slider dragging to true. Yep, that's it. Now we don't have this this insane line. This should work. Maybe. Yeah. Yeah, now I can play with the thickness. What was EXP? Man, I have to name these very quickly. Oh, I know. I think I know what. Look, the middle slider here is the exponential value, right? And I want to change it for the thickness, but right now I'm changing it for both values. Okay, but before I add yet another slider, I will do some stupid naming. So I guess this is pretty simple. We just do a vector of text, slider info text. I was wondering, does my slider have actually a text function? I think it already has, but let's... is that font? No, there's no font. Okay. So when we go here, we add this thing. So this slider info text, push back. Then we set the font. I guess let's make this a little bit easier. So set font. So we obviously have to pass over some string. Description. Why is it not detecting that? Hello? Okay, it does, but yeah. So this is the angle. This is max depth. This is the exponent. Branches. And this is the thickness multiplier. I don't know, it's just called thickness. So we go like description and then one of those. Yeah. Then we have to set the position. So this one should be pretty easy. So it's text position. So the x value is the position.x minus. Oh, we also have to set a character size. Let's also go 22 maybe. So here we subtract this, and then the y coordinate. The positive dot y, and then we subtract 15. Okay. So we subtract half of the visible hitbox of the text, the half of that. It's a little bit confusing, but that's usually centering. We set the position to that. Finally. And then we draw this this vector. Info text. And maybe this already works. It usually never works on the first try, but earlier that happened sometimes, so maybe it works again. Let's see. Yeah, I mean, it's not centered like I want. It's like centered on this middle thing here. But that's pretty good. And I guess we can add some info values later. Oh, nice. I like this description. It helps the whole thing. I guess, why is it not centerized the way I want it? Oh, pause. Yeah, this is plus 15. I guess we can also replace the 15 with slider dimension.y divided by 2. But, oh, beautiful. I mean, it's not... yeah, I mean, that's text, so let's just move this. Let's just add 10. Okay, nice. Nice. Yeah, this makes me happy. Yeah, this is interesting when you have 3 branches and you go like this. Look at that. Yo, that's a fractal. That's cool, man. Just perfect 90 degrees angle, and then you get this. Oh my god, this is Sierpinski's triangle. This is amazing. I didn't know. I mean, it makes sense, but that's cool. Look at this tree. Very cool. Okay. Well, let's add another exponent for... Well, one is for the length and the other one is for the thickness. So we need 2 exponents. So exp thickness and exp length. Yep, and then we need the thickness. And yeah, now we have exp length and exp thickness. Just change all of this. Exp length, exp thickness. I guess I want to correct ordering. Exp thickness. I guess we go to 0 though. Why not? And yeah, I want to maybe go a bit about 1 just for the fun of it. Let's actually add this here. Dot y divided by 2, and then I subtract like 5 pixels. Because I definitely want to make these a bit smaller. And maybe change this to be like that. And for the sake of it, let's also add a slider, because we have thickness but we don't have length. So initial length. And I guess I want to make them side by side. So this is state initial length. And let's definitely rename this, otherwise I just get confused. All of that. But for the length we have like 300 And we start at 200. And thickness is alright. This is initial length. Wait, what? Initial length. I need that. So now I should be able to really control kind of every single variable here. And yeah, I guess I really do want to move this a bit. I just noticed I'm subtracting half of the slider dimension. That's wrong. And then I want to subtract another 30 pixels, please. Okay, there we go. I guess I want to decrease the slider increase value. Just look at these. Looks pretty bad. Slider set hover increase, and let's just go 2 pixels. Okay, this looks better. Not this huge increase. Yeah, and now let's see. So initial length I can modify here. Looks as expected. So now the real fun is the exponential thickness. Yeah, that was what I wanted kind of all the time. So if I add more branches, and here when I had this where I couldn't really see anything. Yeah, I have full control of the thickness values here. Very nice, very nice. And also about the length. Yeah, the exponential length is also interesting. That changes quite a lot, actually. Very cool. Very cool indeed. Yeah, this is pretty cool. I guess it's time to add some coloring, finally. Played very long with these values, but I mean now I have kind of full control, so I consider it to be a success. Very cool. Very cool indeed. Yeah, so colors, and then I want to add these random branches to make it really look like a tree. Because right now it's, I mean, it's cool. It's basically just playing with fractals. Look at that. That's really sick. How it rolls into this. First it's like this snowflake of 4, and then it's a triangles, and well, and then it just collapses because pi is completely up and down, up and down, up and down. Very cool. And yeah, we have 200,000 vertices, and it can handle that just fine. That looks very pretty as well. So what I want to do is I want to make like a gradient, so we start with one color and go into other colors. Yeah, let's do that. I guess we can start like with a rainbow effect. This should be actually just a 1 or 2 liner. I mean, I have to also consider the second color. So we have color 1 and color 2. So it's a seamless transition. Okay, so now we have color 1 and color 2. For now, let's make a rainbow color. So QPL get rainbow color, and here we just pass in a value from 0 to 1. Exactly, we have to calculate the progress. This is depth divided by state.max depth, and the second color is one further, so +1. And this is color 1 and color 2. Not a lot of code. Of course, get rainbow color is an interpolation over a vector of RGBs. And let's see. Oh yeah, that's exactly how I imagine it. Very cool. And I guess I really want to implement some opacity. Oh, I guess? No, it works. Yeah. Looks pretty cool, but it's too many colors. I mean, it looks nice, don't get me wrong, but I want something simple. Like blue, yellow, green, I don't know. I guess I just start, I guess I know what I do. So we just make a vector of colors. And let's just say we start with white. Or we start like with brown and then we go to green. And that's it for now, I guess. Like 100, 255, 100. And then we say interpolation, colors, like this. And now it should go from brown to green, so we have it like a tree. Yeah. Yeah, it looks pretty nice. I guess, ooh, look at that. If I really extend this one, get something that looks very much like leaves. That's cool. Yeah, I guess I want to add some opacity. So I guess I just say like 100 opacity. Does that work? I think it should work. Yeah. Nice, we got some opacity. Very cool. These leaves here. I guess I can go brown, green, and then dark green maybe. And I guess I make the opacity not part of the colors. So here I just want a dark, like bluish green. And then we turn into something almost yellowish. I guess the brown should be more dark. Maybe some opacity. Maybe like this. Oh, I did it the wrong way around. Looks pretty cool though. Reversing the opacity here. Very nice, actually. Very, very interesting, actually. But yeah, let's reverse that. I guess it's just go progress 1 and progress 2. So this will be progress 1 minus that, and this is progress 2. I guess we got 255 minus that, so we don't actually go from 0 to 128 alpha value, but instead 128 to 265, and this way we correctly reverse the progress value. Yeah, now we start at complete opacity and then we slightly decrease over time. Looks very good. Looks like a plant you would see somewhere. Like in, I guess this yellowish tint is a bit weird. Yeah, I guess make this just more visible. And maybe I just remove the alpha. Maybe it just looks a bit weird. And I do want more brown, so I guess let's copy the brown value just once. Maybe name these, so brown. Then we have dark green and light green. And then we simply say brown, brown, dark green, light green. Okay, now we should have more brown. Yeah, nice. That's more like how I envisioned it. Okay, so now that we did the colors, I guess it's time to add some random branching. That's really what this what made me want to do this project, because making this tree, I mean, yeah, of course, very cool work here, but you have seen that before. But with the random branches, man, oh man, let's try to make that work. So when we branch out, I guess we want to have like some kind of a randomness factor, the chance for another branch, and we also have to think about where we start. I guess we can make that random. So we want like a branch out percentage or chance. So let's add that here. Like branch out chance, and let's go like 20%. Okay. So what we do after we add the trees, I guess we say if QPL random event, which is I call it random B, it has an overload for probability, so we say state branch out chance. So if 20% happens, then we want to add yet another tree. So we add another tree and we grow recursively, and now we need another position. We basically copy all of this. Branch angle. Oh yeah. And of course we go, I guess we can randomize like the angle as well. So let's start with this. Should be between like negative and positive delta angle. Alright, and then the position, of course, that's really the clue. Alright, so when we make a thing, a segment, usually we just add these here, and now we have to, I guess, find a starting position not here but somewhere here. So I guess that's pretty easy. We just yeah, I think I know how to do that. So new position, we can normalize this line. So if this is somewhere on the screen and this is x and y coordinate, we try to move it here, and then we can simply divide this point here, where we multiply it by like a random value between 0 and 1, and we get any random point here. And then we move it back here, so we add the first lower point, and then we have the random point here. So new position, so we have pos 1 and pos 2, so we say pos 2 minus pos 1, and then we multiply a random value between 0 and 1, and then we move it back up again. So we subtracted positive 1, so we add that again. And maybe that works. Let's see. I have no idea. Okay, I don't see any branches though. No, I haven't actually set it. So it was 0, because in release mode uninitialized values get set to 0. Okay, yeah, there are some new branches. And they should, yeah, they should spawn randomly. Huh, very cool, I guess. It looks kind of weird though. It's not as pretty as I have imagined it. Huh. I mean, it's not bad. It definitely has something going on. Oh, that was a mistake. That's 21 million. Let's go QPL big number string. So we have some better imagination of what that number actually is. Okay. Maybe if I make that, I like add to the depth so it doesn't go as deep. So I go like depth plus 5. Maybe, oh yeah, maybe that's an idea. Huh, or I go like max depth minus 5. So I allow it 5 steps. Interesting idea. I like that. Yeah, and so we have something like this. Oh, but this messes up the thing. Ah, I see. Oh, that's bad. I guess I can change the state max depth though, right? Okay, maybe this works. So max depth equals, and we add like 4, unless we go bigger. So the min value of state max depth or the depth plus 4, yeah, that should do it. And this is still depth plus 1, so the colors don't get weird. Looks pretty fun. I mean, it looks kind of weird when it starts. And this is also incorrect. Yeah, because these percentages get calculated wrong. Maybe I need like max depth or like stop. Another one. And let's go here and yeah, so we have another variable here. Yeah, now the branches don't look too weird. Pretty funny. Looks kind of like electricity now with these random branches. I guess I want these to branch out a little bit. Like I make it random between angle and angle, but maybe I do it like this. So this is state. Yeah, and then if it's 50-50, then I just multiply it by -1. Maybe this looks better. Sometimes they like go parallel to the other branch and it looks kind of weird. Yeah, it looks better. I still don't quite know how I feel about this. Maybe I have to set like a minimum, because if it starts like here, it does look kind of weird. I don't like it too much. Yeah, if it starts like here, that looks nice. So I guess I make like 1, 2, 3, 4. So it can't branch out if it's less than 4. So this is a min depth branch, extra branch. So here I simply say if the depth is greater than the state, this one, and I guess min depth extra branch, let's just say, what does this have, 4? Okay, let's see, maybe this looks better. I guess it makes sense if you consider like trees, like this branching out to have like a big stump. Here's not really anything going on, so this makes more sense. Yeah, it's quite subtle. Like you don't have too many crazy things. I guess now that yeah, I can also randomize these angles and also randomize how many branches it spawns. My god, how did I never consider that? I can do so much more. Let's do that. Let's change this from a fractal tree builder to like just a tree builder. So I just changed the branch angle to be a random value. So negative to positive. And again, I kind of want to randomize this as well. Now let's not change too much for now. Let's just see this change. That should already change quite a lot. I'm pretty certain. Yeah. Oh yeah. Now this is more what I'm talking about. That looks really like a plant. That's awesome. That's so cool. Very nice. Sometimes you get some really funny angles too. I guess now I realize I don't like the last color. So let's change that. I'm going to be dark green and then even darker green, and go even more blue, or just decrease this. All right, let's see. Yeah, I like this color a lot more. Nice thing. I guess I want to increase the percentage of branching out. Or maybe we put that also on a slider. And I guess I want to clear up some of my sliders. I don't really think I need initial thickness and initial length, I think. They're just kind of in the way. They spam my sliders a bit. Let's get rid of this for now. Add a branch out chance slider. Branch out chance. And this is branch chance, and we go from, of course, 0 to 1. And value is 0.2, and that should be all of it, I guess. Yeah, I really optimized my slider workflow here. Yeah, branch chance, nice. All right, let's see how this works. Yeah, once we go past 4 branches, it really starts spreading out. Looks pretty cool. Now it looks like, yeah, I like this because we get some very much branching now, and then we can decrease it very easily. Yeah, this is just normal, just no extra branches, please. Very good. Oh, I like these trees, man. Okay, I mean, I guess we could like make a blue background and like a simple rectangle here, maybe. I don't know. I'm just having fun. Okay, let's do that. So this would be a vertex array. I guess I make a struct for the background. So this is a QSF vertex array background rectangle. Just some grass. Then we want to draw that. And in it, we pass over the dimension. I guess we want to draw one with the view and the other one not, and that being the background rect. So I guess we don't draw it here. So the grass shall be drawn with the view. So let's see. So the grass is just a rectangle. Resize 4. And then dimension.y. Just loop over this bad boy. And set the color. Let's make our own green, so red. Let's make it slightly red. 255. I guess we do it like this. And yes. And then we make the background rectangle. I think like this. Yeah, that should be it. And then the color, we actually have to manually do. So we make like a top color and then a bottom color. So we want like a darkish blue, so red, green, blue, like 200. Definitely more bright than that, so like 50-50. And then the bottom one, we just make it a lot brighter, like this. And then let's add the background. We draw the background very at the beginning to draw everything on top, of course. So we first draw the background rectangle without the view, and then we draw the grass with the view. So I guess we just remove this because now it's just confusing. And then we have to say init. But there is a problem, which you will see in a second. which is something I didn't do yet, but I kind of, you always have to do that. So, okay, there's an arrow, let's see. Right, we have to pass in the dimension. We should have like a nice sky, yep, and here's the grass. I guess this is a lot more to the left than what I thought. Also the colors are not very good yet. Yeah, the sky is bad. But first, so the problem is if I resize, the rectangle doesn't resize. And that's because, you know, we have to consider resizing the window. So what, you know, we have like white in it and stuff like that. So usually what you also can overload is call on resize and override to see if you named it correctly. And here we pass in the dimension, and we pass in really anything that requests the dimension. So also this. So we kind of call this inside here init sliders. I guess we have to clear the text though, because we push back, and we can call that multiple times. So clear. Yep. And what else? That should be fine. So now we don't. Oh yeah, also this. And then we just call on resize. And now this should work. Let's test it first, and then we change the color so it's a bit more pleasing to the eye. Okay, so now if I resize, yeah, everything also gets adjusted accordingly, and we don't have multiple texts flowing around. We have the tree. Nice. Yeah, very good. Okay, so now let's fix this grass. I mean, look at this grass, it's not good. So this is too yellow. Evening theme, you know? Going into a bit more red on the sunset. It looks kind of bad. This should be dimension.x. Yeah, I kinda like that. Just have some grass. Maybe we just extend this and just make this big. And I guess okay, yeah, this is now a pretty big rectangle, nice. And yeah, I like the background. It doesn't look bad at all. I guess we can like make the grass also go from green to black, or maybe something like that. Yeah, so we start with this green and then we go black. Maybe this looks good. Yeah, does look pretty good. Alright, so one idea that came to mind, as you remember, we had the normal fact tree, just always the same angle. And wouldn't it be nice if we had one more slider to like say how much like left is just normal and right is like a random angle, you know? I think that's a nice idea. Let's implement that. We have this angle, and earlier we had, well, I shouldn't have deleted it, but let's see. Branch angle normal, branch angle random. The real branch angle will be between those two. So it's like QPL interpolation, linear interpolation maybe. Yep. Of this, and then by state value, which we will add in a second. Okay, so what was the normal branch angle? Well, let's first add this one so it doesn't freak me out while I'm thinking. This will be like branch, the fractalness. The higher the more we go into the normal. Let's just call it a fractal. Ah yeah, we calculated we used the progress, which we don't even use right now anymore. So I guess it was just okay, I remember it was progress. times state delta angle times 2, and then we subtract delta angle. Yes, that's it. Nice, I think. Okay, and now branch fractalness. Just go 0.5 for now. And then we add the branch, the slider. Slider fractalness, I guess we have to name it. Here we have another one, slider fractalness. And branch fractalness. Very good. And here we have it. Slider fractalness. And let's actually rename this to create slider. Sounds better, I think. Yeah, that is between 0, 1, and this one, and let's call it fractalness. Okay. That should be it, I think. Before I hit compile, I will show it. Because whenever we change a value in the slider, it randomizes everything. So what we can actually introduce is a seed. So it doesn't, you will see what I mean. So when we do like this, I want to see it like morph. So now it's completely, here it's completely fractal. This worked very nicely. Completely fractal and just completely however it wants to branch out, right? So yeah, but I want to see it morph from this state to this state. So let's add a seed system. So QPL random, which is what I'm using all the time. We have kind of two options here. We can, we can just make a random state. Let's do that. We have our namespaces here. So namespace random. So we want to have a QPL, it's a random engine of 64 bits. Seed random. We have to save the seed, so seed, and then we just use the global random engine. Maybe just say seed. It's not a name clash. Engine seed. We just call this, we can call this now seed. Yeah, we just replace in the grow recursive function. Let's highlight every random instance here. So here we got some randomness. So here we say random engine get generate, and then we pass in this one. And then this one, random engine generate B. Okay. Give me another random. Here's another random, and here's another random. And this is generate 0, 1. Okay, so now this is interesting. Because on certain slider values we want to reset, just want to reseed, right? Like if we change the maximum depth. So I guess we might add like a boolean here, like reseed. So if we change the angle, we don't want to reseed and stuff like that. You get the idea? So if we change the depth, yes. This one no, this one no, this one no. Fractalness, no. Wait, branch out chance is a yes. No, let's not do that. I guess depth also isn't it? So what actually changes my my seed? Yeah, I guess I just have to add like a button, like randomize. Well, first of all, seed random, and I guess we could just call this actually reset. So whenever we recreate the tree, we say random reset. Now we should always have the same seed. Okay, let's see. Nice. Yeah, this is good. And now we can morph from this to this. Yeah, awesome. The seed works. I'm proud. That's very cool. I can't deny that. I guess I just here's the thing. I get rid of the opacity because I don't like this, you know? And I just changed the very last color, also this color gradient. Like look at this bright green and then it goes dark. Yeah, I changed the last value to have like 0 alpha. This is not really dark green, this is just green. So let's not lie here. And this is dark green. Okay. Yeah, let's check out the color and then I want to add a randomize button. Okay. Yeah, this looks better. Kind of. I'm not sure. I mean, yeah, it does look better. Like, oh, I didn't. Oh my god, I have to, of course, remove it. This one here. So we don't actually need the progress. So now we should have no more of this opaque branch visibility. Yeah, we don't. I guess this affects the seed. No, no, it doesn't. It doesn't quite do it. Look at that. That's really cool. I mean, I can't lie. I like this. And branches. Oh, it resets the seed. Yes. Okay. Okay, this is interesting because none of these functions actually reset the seed. If you look at the very left one here, this one doesn't change. If I change this, see it? Because this is always the first recursive branch in the function. So that's interesting. So let's actually add this back. Reset, or let's say reseed. Now let's make a hack here. Selection and replace this with false. And then we want true for branch or chance. So if reseed, we say random seed random. Now if I were to change the branch or chance, we shouldn't have this left behavior that I just described. Oh, fractalness also resets the seed now for some reason. I don't really... Oh yeah, of course, because if value change... Ah, okay. My bad. Of course I have to put it inside the if statement, otherwise it will just always get changed, because, yeah, obviously. Yeah, now the angle doesn't affect this. And branch chance completely randomizes the thing. And everything else stays the same. Okay, now with the opacity, this just looks so much cooler. I guess this makes me kind of wish the first one was a lot longer. Maybe I can just hard code that. Yeah, you know what? If depth is 0, then just double the length. No, yeah. This looks so much better. Okay, I'm happy with this. And then, nice. This is so cool. That's some mad stuff. Like normal tree and then just this weird shape. Okay, now I have yet another idea. Let's make a forest, you know? I mean, I have this class tree builder. And I can just make more trees and then we have a little forest. Let's do that. Alright, so let's just let's add a forest, which is a vector of tree builder. Of course we copy the... no, we don't copy the draw function. We no longer have a draw function. I mean, I guess it is here, so yeah. Just move this always one step up. Okay, and now we just want to call grow with a number of trees. And dimension for reference. Okay, and then trees, resize. And yeah, I guess we just randomize the x coordinate. Let's loop over this and then, so we can just randomize this. I guess we also use the seed. Yeah, we use the seed. So random engine generate. So we want like negative 1000, negative 500 to dimension.x plus 500, I think. And then we simply say tree.grow at position. Wait, does grow? Yeah, grow calculates this, so we have to remove this. Now we no longer have a tree, we have a forest. Okay, this is a bit tricky because I have multiple Wait, I could also pass over the grow state. Huh. I mean, these are the same variables, kind of. I mean, in general, couldn't I just replace this with this? I think so. Yeah, I got this. It's equal to 4. And yeah, I just pass over my state. And okay, let's replace this. Yeah, and now I simply make a grow state here and copy it from the first value. And here just says state dot. So we basically only manipulate one variable and then pass it back to all others. That should do the trick. 4 out of 3 in my forest trees. I guess I don't pass the size here, I just make this internal variable. Let's see, now we should have a forest. Wait, this is just one boy. But why? Oh wait, I think I know why. Yeah, I know. Because we clear the VA here. Ah, gotcha. Okay, now we should have two trees actually. Yeah, there we go. Very cool. Very nice. So let's make the 15 trees. Oh yeah, look at that. We got a little forest here. But it is quite laggy and oh my god, yeah. I know a performance upgrade. So the grow recursive function is very slow, and it's especially slow because we always have to pass down this state here. So it would be faster if we only pass the reference down and change it as we go. So this will change a bit of stuff here. But before we do that, another, just cleaning up the code, we wanna, when you realize, okay, the project is getting kind of big, I'm losing a bit of my, I'm searching a lot, then it's time to add some more files. So what is the first file here really? I guess it's this one, all this data here. So let's call this data.hpp. And copy all of this here. Then we include data. Next we add the segment.hpp. Okay, then we have the tree. Just paste that here. And yeah, we need the data and the segment. And the grow state, I guess. Okay, what else have we got? We got the tree builder in the forest. So let's just add the tree builder to the tree. Then we have the forest. Okay, nice. Let's just add one more for the background. So we just have the main state and we have a lot more clear structure. Nice. Alright. Let's hit compile and see if we broke some things, you know, the usual stuff. Nope, it still compiles. Okay, so, you know, like I said, I want to improve the speed of the generate recursive function, because as we pass down the state, this will always get copied, and that's bad. And I guess we can put all of these values into this growth state, maybe. Or maybe we make like another struct here for the recursive state, which holds a growth state, maybe just info, and then we have the remaining variables here. So all of this. So here we can replace every state dot with a state dot info dot. Alright, this should now all work out. And then all of this we just have to add state.depth. But of course we have to not do this, we have to actually increase and decrease these values. Okay, so this, yeah, we have to change, no, that's all fine. Once we go into the function, we have to actually change these values. Okay, so state per starting position becomes pos2, but we have to revert back, so we have to make actually I wrote that completely wrong. that must have been an error for quite some time. Okay, anyways, pos before, and this should be all the changes. Now we have to do the same thing here. And that should be it. New position, everything considered, yes. Okay, then we have a error here. Stop depth before. And let's also make this here first one, first out. Okay, maybe this works. Yeah, and here we pass the state. And yeah, this works out, so we just copy this. And then we have the angle equals minus pi over 2. And the depth equals 0. And the position is the position here. Nice. But still, let's see. Okay, this is still pretty slow. Maybe we have 5 million vertices here. I wonder why it's so slow though. Like we have no vertices, but something is wrong. What is this? Yeah, the stop depth doesn't go down. So we have to update that somehow. Maybe just like this. Okay, yeah. Now we have some freedom here. Nice. Alright, so I changed some things. I made an extra file here for the state, and in my tree function I basically just call a segment create and you know, just putting moving some code. And next I thought it would be nice to randomize for each tree in the forest the initial length and initial segment. So let's, I don't know, let's just go with between 2 and 6 for the length, for the thickness, and for the length, maybe 100 and 300. And let's make this, let's go with like 24 trees here. Again, get this back here. So maybe we get some variants here in the forest. Okay. Yeah, pretty cool. And maybe we can add like a value for each, like they have different shades, you know, so some are darker, some are browner. But so far I already like this quite a lot. Pretty cool. Yeah, we can make some little forests here. Yeah, so we just have to add here to the state. So what do we want to add? Or maybe we just add like, maybe just some traits. Maybe like likeness. Yeah, let's go with that first. The colors will be changed. So if state traits, let's say if that is less than 0, we want to darken it. So we interpolate black according to the traits lightness. Also the color 2, of course. And otherwise, just interpolate towards white. And here we say lightness, and then we just say random between. And let's see, maybe we now see some different shades for these trees. I guess we can make like a Z coordinate. Oh, I guess I didn't call my seed. You will see that immediately. Yeah, pretty cool. We see some different shades here. Get some interesting trees here. I guess we want to extend this range here a bit. And maybe make these a little bit more extreme. Nice. Get some cool looking trees now, and yeah, they are not too stacked. Okay, here's my idea. So we can start like in the background making some big trees that are quite dark, and then the further we go into the foreground, maybe the smaller they are, so we get like a depth field of view. I think that's an interesting idea. So let's just change this loop here to be a for loop. And then the progress, of course. Okay, so the position we make it stay random, and then the other values we make according to this. Maybe let's rename this to like Z coordinate, you know? Maybe we multiply it by some value. Like 10, so at the start we have 10, and then we go smaller and smaller. Just try like this for now, but this is probably too much. And then the lightness, yeah, the lightness, we just go from dark to white. So yeah, so we go from -1 to +1, so this is simply Z minus 0.5 times 2. Alright, we just set it to be that value, I guess, and maybe divide it by 2. And this should already give us some interesting perspective for this forest. Okay, it's kind of reversed. Yeah, the length is reversed. So we remove the 1 minus here, and also a length z. Yeah. Oh my god, this is super small, and then we have these huge trees here. Pretty interesting. Yeah, that looks already kind of like a forest. And I guess what we can also add, maybe the further the trees are in the front, the less depth they have. So I think that's also an interesting addition here. We can also like do it like this. Yeah, so the trees in the very front have half the number of depth, and in the back they have the normal depth. So let's see if this works. Yeah, that looks nice. That looks pretty good. Looks like some tropical forest. And changing a bit with these values. And yeah, I also realized when making these big trees here, I guess I don't really want to play with this branches value. Because, I mean, so yeah, let's just remove this for now. Like a namespace config. Use branch numbers. Yeah, that's pretty good. So now I comment it out for now. So I see where I have to add the if cons expression. Okay, where else? Here. And here. That should be it. So now I can commit it back in. Yeah, now I don't have this setting anymore. Yeah, I also want to do, if we are at the last branch, I want to make the alpha 0. So we have, yeah. Oh, I guess it's one more. One less, I guess. But one idea while playing around with these numbers, I haven't randomized the length. I mean, I have randomized the branch, you know, the branching, but I can also randomize the length. And I think that will make the forest look even cooler. Or maybe I don't do any sort of opacity, because zooming in it looks weird. Maybe I just make the width to be 0. That's actually just the idea. I make it like a triangle at the end. Okay, so in order to do that, let's go to data. So we remove this alpha here, and then yeah, this is the idea. So here, if the state depth is 0, thickness 2 is 1. So you get a very sharp ending. I think that will look a lot better, actually. I don't know, like these ideas, I'm like, why have I never considered this before? Yeah, this looks way cooler. I think. I don't know what you think, but yeah, this looks better. I'm happy with this. Well, especially if we go big maximum depth. Looks very cool. And look at this. This is a weird forest. I mean, it is a forest, and then we go like this. And you just get these octagonal things that change based on the shape. Pretty funny. Okay, but let's add random branch length. Again, ideas that I could have considered like way earlier, but it's never too late. So here, we calculate the length, but we can make some random adjustments. And I guess that's another variable for the state. Yeah, like delta length. And then we can also put a slider on that later, but first let's implement this. It's actually very simple. well, we create a random value between 1 over state info, what is it called? The length, delta length, and then state info delta length. So I guess it has to be above, the initial value has to be 1. Yeah, and then you have like 1.2, 1.3. And we multiply the length by that. So I guess we just add a slider for delta length. And this is going from 1 to, I guess it can go pretty big. And let's start with 1 or like 1.5 delta length. And we plugged it in here, so slider delta length. And also we draw that. I think that's all. Okay, let's see. I guess it doesn't quite work for some reason. Alright, so I added a tree count slider, so we can add or remove some trees here. Also, I wanted to, because you know, the first tree will always stay the same, because I'm not recreating the seed here, and I guess it doesn't look bad, but I just want to have a button where we can randomize the seed. And when we are thinking about the HUD, what comes to mind is I want to hide this overlay here. And first I thought, well, maybe I make a button like H, but that's a bit weird because you have to basically just spam your keyboard to find out all the hotkeys. And I don't really want to add a menu right now. This is not too big of a application. So what I thought about, I want to make a hitbox here. When I hover here, it becomes visible. If I go away, it fades away. So what I already did, alright, so what I already did, I made a hitbox for the HUD, so HUD hitbox. And I want to show you that, so let's draw that. And we go, when the mouse crosses this area, then we fade in, and when it goes out, we fade out. So here is this area, basically calculating while we are adding the sliders. And yeah, what I will be using is my QPL animation here for, this is basically like it goes from 0 to 1 and we go backwards, forwards. It's very easy to use. And in order to know if we go outside or inside, we have to save if we were in before. So let's go here to updating and we check if we are hovering. So if we are hovering, but we were not hovering before, then we want to fade in. So basically the animation, we go forwards. And then else if we are not hovering, but we were hovering before, we go backwards. And then of course we save the hovering value. And then my animation class works like this. So we say, we call update. And then if this is running, we can get the progress. And what I like to do here usually is get the curve progress. So it's not like a triangle, but it's like a smooth curve. And now we just have to change well, the alpha value of every slider and of the text. Well. Okay, so alpha is progress times 255 and cast that to a U8. Yeah, and I guess it's just going through all the sliders. So, and we will also do the same for every text. Slider info text. Okay. Let's try it out. Ah yeah, the default animation speed is 1 second, so it takes 1 second to be completely forwards or backwards. Yeah, yeah, as you can see, so we are here. When I go out, it fades away. It looks pretty good. I can't complain here. Maybe make it a little bit faster, or maybe make it fade out more quickly in than it fades out. So if we go forwards, we set the duration to be 0.3. Of course, if we go backwards, it's back at 1. I guess at the start, here we go forwards. So this animation go forwards. So let's see. Yeah, so it goes on. And I don't know about you guys, but I don't like it that it completely fades out. So maybe I just I want to do like 0.2 alpha minimum. So let's make offset like 20% or like 40%. So we multiply by 1 minus the offset and add the offset, right? And now it should never go below 40%. Yeah, alpha channel. Maybe fading out can be a bit faster. This is a bit unsettling. So 0.5. Also, yeah, if we go forwards, we have to, yeah, set the duration. So I guess I still will add the age button. Just in case you want to make like a cool picture, or I don't know. Yeah, this looks pretty good. Yeah, so let's just make a boolean display HUD. I guess this also became quite a bit of code, so let's make a void update hover HUD hover and get all of this here, so we have some more structure. Update HUD hover, and next if event key pressed, I guess key single pressed actually. I don't want the BIOS key press. So if we press K, H of course, then display HUD becomes not display HUD. No, let's just say if this display HUD, if it's not, then we actually say allow during true, because I thought about that for a second. That is important. But where does that actually happen? Yeah, any slider dragging. We have to set that to false. Okay, I got it. Yeah, I guess I can return here, so we don't have duplicate code. And also, we only draw if it's visible. So if this display HUD, then we draw. And also, yeah, we have the vertices text here. I guess the ordering is a bit wrong. Okay. Nice. So now if I press H, the HUD will be toggled off or on. Yeah, nice. So we get rid of that. I'm happy. So again, let's make a button here for, you know, randomizing the seed. Because I talked about that so often, and I do indeed want this. So let's make a nice button. Let's use my smooth button. It's of course QSF smooth button, and this is the seed button. And we draw that. Okay, so this seed button, let's set the font. Let's set the string to be randomized seed. Let's set the position maybe that at the top left, and that like 50 pixels below it. So chronologically we start with this. This one not. Okay. What else? Set dimension. I guess like 150 is enough, although then we have to go 70. Yeah, that should be it, I think. So now we update this button, this seed button, and if it was clicked indeed. Oh, but we also have to, if the display is visible. Then we call random seed random, and we regrow the trees. Forest, grow, dimension. Yeah, I guess that's it. We have to, yeah, we draw the button already. Alright, so let's take a look at this button here. And for my smooth button, I haven't added a hovering animation by default. Especially because usually I want to go fancier than just on off. But yeah, here's the button, and as you can see, if I click it, it's randomizing the seed. Pretty good. But yeah, let's add a little animation here, also make it a little bit wider. And also change the text color to be white. So yeah, I guess we add another QPL animation. So this is seed button animation, and also care about hovering before. Also this is false by default, please. Okay. Let's minimize some of this here, please. Okay, so here let's make a hovering check if the seed button is hovering. So again, you know the deal. So if hovering, but we are not, seed button hovering before, the seed button animation goes forwards, otherwise goes backwards. Well, not otherwise. We have to go else if not hovering and hovering before. And after all of that, let's not forget to change this. I guess I didn't do I did else if, okay. So now we update the animation, and then if it's running, get the progress, get the curve progress, and yeah, so what do we want to do? Well, I guess we do some simple interpolation. So the background color is black interpolated to white. White is kind of bad. Let's go like a gray shade of 100 with the intensity of progress, and the text color is white interpolated, maybe just a bit darker, or we maybe just don't touch the text color. Yeah, and then the seed button set background color. Maybe this looks good. But this, again, the default animation speed is a second. So let's change that to be like 0.3 seconds. And let's take a look at this. Maybe we have a nice simple animation for the seed button. Yeah, it looks pretty alright. I guess the animation should be a lot faster. Yeah. Also, I don't like the transition color at all. But that's easy fix, of course. Play a bit here. And then we interpolate to, I don't know, let's just go like cyan. I guess also make the font a bit bigger. And maybe just call it randomized so I have more text fitting on it. Yeah, I like that. And if we press H, very nice. Yeah, nice. Okay. There you go, red. Maybe go here with a dark blue. So red, green, blue. And what else? Oh yeah, changing the text here. Going like 22. Let's see how this looks. Yeah. Okay, I like the text change. I don't like this blue. Looks weird with the background. Ooh. I mean, it's kind of overkill, but I kind of want to, like, if I click, I want another animation on top of the text color, you know? That would be kind of fun. Alright, added a subtle detail here. Like I said, so if I click here, it goes blue very shortly. I thought that's kind of neat. But anyways, so that was a lot of overkill. I guess one thing that I just see right now. So this is all very white. I guess I can decrease the width of that, and also maybe add a nice background, because you know, if it's like this, it kind of looks a bit ugly. But this should be very easily done. So I already saved the HUD hitbox, so I basically just make a smooth rectangle. Alright, so we set the hitbox, then we set color, let's go black. And that's basically it. Yeah, and then we draw that. We already do, so let's try to compile this. Oh yeah, there's the background. I mean, I guess now it's the time to include this text here finally. I guess let's just add a max slider text width, and then we can change the background hitbox according to that. So inside here, so this will be the maximum value of itself, or text get visible hitbox dimension X. And after we are done here, we can just move the hitbox. So position, we move by, why is this not working? By this? I guess we move backwards by the X value to the left. But then we also have to increase by what we just moved. Okay, I guess let's add this here so it's a little bit more clean. Yeah, we just say set hitbox of this hitbox and set the color to black. And there seems to be an arrow. Okay, yeah. Maximum function, of course. It struggles with two different values, so this is a float and this is a F32. So I guess you just change this to be 32 as well. There's really no reason to get more precision when the value you try to find out is not even that precise. Okay, and yeah, that looks pretty good. I mean, we increased by 50 in both directions, so I guess we can decrease that a bit. Maybe just increase by 10, so we actually get the corner as well. And I guess this is the time to move the whole thing, so we actually have more space here. Also I wanted to decrease this width here. Let's actually do that right now. I mean, it was 600 pixels, which is pretty absurd if you ask me, thinking about it. Yeah, it looks a lot better. And yeah, I guess we also want to decrease the alpha when we fade out. So let's do that. So here's the update hover. And then we also want to set multiplied alpha. I guess after we set this hitbox, we might just increase this again to extend over this background, because it's a little bit of a miss if you go here. Oh yeah, that looks pretty good. You have this nice slider here, and then if I go away, it goes away. But yeah, I can like go here and it fades out. That's pretty bad. So after that, let's increase by 40 pixels. We should be fine with the HUD. So yeah, we have this HUD here. We go away, it fades slightly away with this nice background. Overall, I'm pretty happy with this overlay. Alright, so I made some little more adjustments. For example, when we branch, I want to have a little bit more randomness here, because I noticed some very similar angles. I also again included the use branch numbers slider, and in the forest here I played a lot with these values to make the forest generation look nice and stuff like that. But yeah, just some final touches here, and now I will be going over the final product here. Okay, so yeah, we have this nice little forest. But yeah, why not just start with the basic? Let's get all these settings to default. So we started with something like this. A fractal tree where we split by 2 every branch and get this cool looking fractal tree. And then yeah, I added some settings like the angle of each branch, the maximum depth, of course, some diminishing values. For example, as you can see, the length is getting smaller and smaller, but we can change that or make it very small, so we get some very big recursion here, and it looks a bit buggy, but yeah, because the thickness was a bit big. And yeah, this way you get like some really deep recursion going on here, as you can see. Yeah, I also added some branches, so we can also go 3 or even like 4 or 5. I mean, you can really add any number you want here, but 2 is pretty nice for just some nice trees. Yeah, and then to make the tree look maybe more natural, I thought about like adding some branches, so we get a bit more, you know, some more branching going on. Can look nice. And then also I played with the idea of just randomizing the angle, so I can actually switch between these values here, so we get some more natural maybe looking things. Also, you can move or you randomize how long each branch shall be, and then you get some nice looking ferns, or well, I don't really know how you would call this, just some friendly trees. And yeah, can play making some somewhat realistic looking trees. And yeah, always kind of funny to see the fractalness still turning that value up. And yeah, overall some funny settings here for sure. Yeah, and then the next logical step was adding more trees to get like a little forest here. Managed to get some decent performance, as you can see, like 100,000 vertices, but we can very efficiently move all of them without real lag here. And yeah, just making a big forest. And yeah, I made it so that in the background you have some higher chance for trees, and the further you go, the less depth they have, and also the lighter the color and stuff like that, to just make it look a little bit more like a forest. I think it turned out very well. It was definitely a good lesson also for me to just practice, you know, getting some recursion right again and some performance with that. And overall, just pretty funny, especially, I mean, fractal coding, the fun writes itself. It's the ideas come very easily, and yeah, I managed to really do this whole thing in one go. So I spent like 6 hours on this now. But usually when I'm like when I have fun, I really can't stop. So yeah. But yeah, I wanted to show the final product here because I think it looks pretty neat. Of course, there will be a GitHub link to this little project. And yeah, so thank you for watching this video. And again, I might do a part 2 on this or not, I don't know. But I will definitely do more game coding because I have quite a lot of fun, especially relieving some of the pressure by having to maintain a small library and stuff like that. I will just use my casual setup and yeah, make some videos with that. Just do it like this. Again, in the future, I kinda really want to do like even just this plain C++ tutorial, going really over the basics, and yeah, then maybe even making a very basic SFML tutorial, and again going step by step through, for example, my QPL library. But yeah, right now I will be just doing some casual programming really, and making some videos of that. So I hope you enjoyed, and thank you for watching. Bye bye.